Real fast, I'm going to talk about measurement and accuracy, the difference between those and how to use it, how to read a graduated cylinder is mostly what we're spending time on. So first, reading the graduated cylinder, you always want to read at the bottom of the meniscus when at eye level. So you can see in the picture, your eye level should be at the bottom of the meniscus. The meniscus is a curved disc-like structure-looking thing inside the liquid. Inside your graduated cylinder, you read the bottom of that. And that's just because of surface tension. The sides of the water will be up the side of the graduate cylinder. We're going to read at the bottom of the meniscus whenever you're reading anything, a graduate cylinder or anything else that you're looking at. You'll be reading that bottom of that meniscus. You also want to make sure you're eye level, so that doesn't mean that you hold the graduated cylinder, whatever you're using to measure, you don't hold it up to your eye level because then you might be holding it sideways, or you could spill or drop it or anything else like that. So usually the best idea to get at eye level would be to set it down and then kneel down next to your lab station to where your eye then becomes eye level with it while it's sitting down on a solid surface. There's there's different types of graduations on a graduated cylinder. There's the major graduations, which are our larger tick marks. You can see we have 20, 30, 40, 50 here. Those would be our major graduations. They're usually labeled. They have a specific measure value that's telling you what their value is right next to them, right on them. Your minor graduations are the smaller tick marks between. They're usually unlabeled because that would be congestive to have all these little numbers along the way. So you just have to use the major graduations to figure out what the minor graduations are worth. So what you would do is you can take 30 minus 20, you subtract the difference between your major graduations, and divide that by how many spaces you have between. So 30 minus 20 is 10, so this would be equal to 10 milliliters between the two of these. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces between there. So that 10 milliliters divided by 10 spaces, each line here must be equal to 1 milliliter. A good way to double check that you've done it correctly is to count up by the value you've decided. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And then make sure that it does match when you count up by that value. It matches what you're getting between your major graduations. That's a good way to double check. So if I was to read this graduated cylinder here, I already know that each of these tick marks is equal to 1 milliliter. I'm at 30 here, 31, 32, 33, 34, 35. I'm about at 36 milliliters there. A good rule of thumb is to usually guess the next decimal place. So if I'm at 36 milliliters, I could say that maybe this is 36.2 milliliters or 36.3 or 4 or 5, somewhere in there. That next decimal place over is going to be a guess, and it's an estimation as close as you can. I'm not so much worried that you get those down, but you will need to know how to do that someday. So whenever you're guessing, you're just guessing to the next place value. That's your uncertainty. You're not 100% sure on 36 point what, but just put 36 point what you can get as close to for your estimation. A little bit more practice, so remember you find the value of the major graduations. So here we have 50 and 40. So the difference between that is 10. You count the number of minor graduations between the major one. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So 40 to 50, 10 milliliters divided by 10 spaces. Each space must be equal to 1 milliliter. Then I'm going to measure the bottom of that curved line. Remember, at eye level, measure the bottom of your curved lines. So 40, 41, 42, 43 milliliters is what I would go with. And then estimate one more place value. It looks exactly on 43, so I'm going to put 43.0 milliliters for this value here. Go ahead and see if you can figure that one out yourself. So remember, you're going to do the 70 minus 60 and then divide by how many spaces and then count up that many spaces. So if you look at this one, you go 60 there, 70 minus 60 is 10 again. 10 divided by 10 spaces is 1, so each one's 1 milliliter. 60, 61, 62, 63, 64, 65, 66, 67, and then I'm going to say that's right on maybe 0.1, so 67.1 milliliter. So when you're estimating the next place value, that's unmarked, not even with just the tick mark. So you just go to the next decimal place there. Be sure to label with the unit every single time. Do not forget to do a unit. You need to have a unit or else the numbers mean nothing. On your graduated cylinders, there is a milliliters mark that will tell you, or something else like that, that will tell you the value, the unit that you should be using when you're measuring with those values. So these ones I'm going to use milliliters. Down here I'd use milliliters. It will tell you every time what you need to use on your piece of equipment that you're using. Down here on the bottom it tells us milliliters. This one at the top tells us milliliters. More often than not, you will be measuring a liquid in milliliters, and your milliliters will always be pretty much what you're always measuring when you're using a graduated cylinder. Next, we have accuracy versus precision. Accuracy is just how close the value is to the actual or accepted value. The smaller the marked increments, the more accurate you can be with that equipment. So a graduated cylinder has small accurates of, if it had tick marks equal to 0.1 milliliters for its minor graduations, when you compare it to a beaker, which is pretty much bigger like a cup, and it had 20 milliliter increments for its minor graduations, you could be a lot more accurate with something that had 0.1 increments, because you can see exactly if it's going to be 12.1 versus if it's just going to be between 20 and 30 or between 10 and 20. You can see exactly more specific if you have those more increments. The smaller your marked increments, the more accurate you can be. An example of an actual measurement of 12.32 milliliters, if you said 12 milliliters, that's more accurate of a measurement than 13 milliliters. So to use accuracy in terms of if you're doing a lab and running multiple trials, accuracy would be if you took like the average of 4 different runs and found that you were really close to the actual measurement when you took those 4 runs, or maybe you were right on the bullseye for all of them. So a good example for accuracy and precision maybe is to use like groupings. If any of you are target shooters or do archery and stuff, you can definitely use groupings. That helps you understand. So accuracy is when your average is really close to the target, or maybe all of them are right on the target. Precision would be different. Precision is how close they are to each other. So if you're very close, all your groupings are really close. That means you're repeating the same experiment multiple times. You're getting very precise results. You're getting the same results over and over again. That means you're doing a very precise job. Does not necessarily mean that you're close to what you should have been getting. So you might not be close to the target or very accurate, but you are precise. You're getting the exact same measurements over and over. When you're precise, that's a lot better, because that means that you are can figure out what you're doing wrong to become more accurate then, what you can fix. If you're all over the place, not accurate, not precise, you don't know what you're fixing. You're probably just getting completely different answers all the time, and it could be something you're doing wrong one step and then you do a completely different thing wrong the next step. So you can't just find the problem and where it lies. When in terms of equipment, when you're thinking about precise, the reproducibility of discovered values, if you can get similar results each time you do an experiment, the more decimal places you can label with certainty. So again, the more minor graduations, the smaller the value of your minor graduations, the more precise that piece of equipment is. So again, the same idea here. 12.32 milliliters is more precise than just saying 12.3. If we compare our graduated cylinder and beaker again, graduated cylinder with 0.1 milliliter increments is going to be way more precise, because I can say 12.1 with certainty because I see it's right on the 12.1 line, versus if I had a beaker, I could just guess and say it's somewhere between 10 and 20. I'm not even sure if it's on 12 milliliters. So the more precise you can be, precision, accuracy are a little bit different, but in terms of equipment, the more accurate equipment is probably also your more precise equipment. The more accurate you can be is by using your more precise equipment. So if we go into equipment again really fast, accuracy, the more accurate piece of equipment would be the one with the smallest graduations possible for that measurement. It's not accurate to have to measure twice. So the most accurate piece of equipment depends on the amount of liquid you need to measure. So if you were going to measure out 30 milliliters of something, but your graduated cylinder only goes up to 25, the graduated cylinder, even though it has smaller marked increments, it isn't going to be as accurate, because you'd have to measure it twice. You'd have to measure out 25 and then 5. That's 2 different times that you could have an error. 2 different times that you can mess up. So actually in this case, you'd want to go with a bigger graduated cylinder that has maybe even bigger increments, but you only have to measure once then, so that'd be more accurate. Volumetric flasks are the most accurate for most liquids, because they have a very specific measurement and they have kind of a bottleneck that comes at the top. You can measure out that exact spot, gets very accurate for high amounts, but they can only measure out the specific and exact amount. They only have that 1 or 2 measurement spots. Precision, the smaller the graduations, the more precise the piece of equipment. So a 10 milliliter graduated cylinder with minor graduations is much more precise than a 400 milliliter beaker with 50 milliliter minor graduations. So accuracy and precision, this is where it gets hard to kind of figure out the difference between the two. Precision is a set thing. You're more precise if you can get those smaller measurements each time. So the smaller marked minor graduations are going to be the most precise equipment. Accuracy, not always, because it's not always going to be the most accurate piece of equipment if you're going to have to measure twice. So I can't use a 10 milliliter graduated cylinder if I need to measure out 50 milliliters because that's going to be difficult. If I only had the choice between my 10 milliliter graduated cylinder and my 400 milliliter beaker, I would be more accurate to use the 400 milliliter beaker and try to get it right under my 50 milliliter minor graduation mark. Just because measuring 5 different times at 10 milliliters leaves a good chance for error. So that's accuracy and precision in your equipment. There are questions like that on your test or your daily quizzes.